Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Bismillah ar-Rahman ar-Rahim, ladies and gentlemen. Let's continue our HVAC tutorials. In this video, we're gonna complete our Revit tutorials. In this video, we're gonna start the duct drawing and the air handling units. Here we have our building, three levels, and here is the roof. We have finished the mechanical settings. The last tutorial we talked about the settings, okay, and how to the basics of drawing the ducts in Revit and what you wanna. Okay, and here we have here is the air system. Okay, air system by HAP. After finishing this the cooling loads, let's take a look on at the project. Okay, here we have the weather and the 29 spaces. Okay, and here the systems for here for the corridors and the shopping zones. Okay, and here the 29 zones, and here are the systems, and here are the plans and buildings. Did not do this for here, and here with the schedules and everything that we talked about in the tutorials of hourly analysis program, and then you can generate the report, okay, like this. So here is the report. So here are the number of zones, 26 without the corridors, and here are the floor area, and here are the locations in Cairo, Egypt, and the air system type VAV and chilled water air handling units. And here are the calculation amounts, and then you'll find the maximum CFM, okay, maximum block CFM at July at 1600. This is the time, and here is the maximum CFM. And here is the ductwork that was carried out by AutoCAD MEP. It was a rough drawing. Okay, we may not need it now. Okay, and here is the distribution of the duct work. Okay, we now we are gonna need only these calculations, or the maximum CFM. Okay, and here the corridors. I think here we used one air handling units for the corridors and for the zones. Okay, so we're gonna just follow the CFM distribution for each room. Notice that here the heating was used, and here are the zones. Okay, and everything you need, you will find it here. Okay, now we have to select the CFM. So suppose that this is the maximum CFM plus the CFM of the corridors. There is another report for the corridors, and I think that we added them together to know the maximum CFM that will be used for this area or for the whole building. You may use an air handling unit for each zone or for each area as you like, but here we are gonna use one machine. So suppose that the maximum, and here the 14415 CFM for the corridors CFM, and here is the maximum CFM for the corridors 7753 plus 14415 is equal to, so the total CFM is for the building is 22168 CFM. You can use one air handling unit to provide the building, the whole building, or you can use many air handling units. This is up to the senior engineer and according to your experience and the losses and the cost and many things. Okay, now we have to start in the level 3, but before this we have to select the air handling unit. Let's take a look on the air handling units, chilled water air handling units. Chilled water air handling units. We found many catalogs, and they work with the chiller. We're gonna talk about the chiller later. And here is the thermostructure, storage system, and many things that's related to the air handling units and the fans. You have to know how to select the air handling unit based on the CFM and based on the calculations by early analysis program or any other program. Okay, so here you may get this from any catalog. Okay, here the air handling unit CS series. So here is the air velocity in meter per second. You have to know the appropriate air velocity for this zone. Well, here the velocity is the recommended maximum duct velocities for conventional system. You may use these values and any other values that's related to the air handling units, or the maximum recommended air velocity. Here are the main ducts in foot per minute and something like that. Okay, so okay, suppose that we wanna 1200 foot per minute. It's gonna be higher. So here is the range. Here you have the range in meter per second. So you have to know maybe this is the mid range. So we may use 2.5 meter per second. I read the converter. Here the velocity 2.5 meter per second, feet per minute. It's 492. Okay, so you have to know, so you may use 2.5 for this building. Okay, so 2.5, and the other thing you have to know is the CFM. We have here the total CFM is 22,168. 22,168. You have to know which is appropriate for you, and you may use 250 or 300 according to the calculation. So it's, for this tutorial there are very rough calculations, and you have to be sure of the foot per minute, and you may use another recent schedule or numbers, recommended numbers for the ranges for the air handling unit selection. Okay, and here is for the main ducts, and so here the main ducts are washers and many things like this. So it's we're gonna use a rough number, so 2.5. You may use 2.5, and you may use 300, and here is the cubic meter per hour. Okay, so the 300, then we have to check out the CS series. These are the air handling units, CS series. We'll find every thing here about the air handling units, and now we have to take a look inside the AHU here. So here is the fresh air intake with louver. So let's suppose that this is the air handling unit. You have to find the supply air and the return air and the fresh air. So here this is the fresh air, exactly like this. And according to the CS 300 that we selected here are the dimensions, the full dimensions of the air handling unit B and C. Okay, and here is the L1. So L1 length and weight. Okay, this is the length. And if you wanna use mixing box, mixing and exhaust box, panel filter, back filter coil, electric heater, droplet, emitter, and humidifier, and also here are the fans and the absolute filter, multi-zone, sound attenuator, and the supply air plenum. Okay, you have to know which devices you wanna select exactly, and then you have to add their lengths. Okay, to know the total length that you want. Okay, so you have to pick out the CS according to the total CFM for this zone. CS 300, here are the dimensions. So first thing here, we're gonna add this here, mechanical equipment. Click on the mechanical equipment. You will find here the list of the equipment that are added by default. If you do not see what you want, you can click on load family, and you have to know that here, click on view and show hidden files. you have to open program data, and I think Autodesk. You'll find here RVT, RVT 2015. I think that here you have to make sure that RVT is here. So this is the library, and open here the options, and file locations. You have to here are the construction, here are the templates, 2016. Okay, here are the templates, and the default path for the users files. Okay, and the default path the template files, I changed it to this location, RVT 2015 here. Family templates English, these locations. Okay, this is the right path, and here the root path for the point clouds documents. Here for the places, you have to know that the Imperial library is here in RVT 2015 libraries. Okay, there is US metric, and here, okay, this is the path, exactly US metric. You have to US metric. Okay, here is the library, and also for the detail library, it is libraries US metric, but you'll select the detailed items. Okay, that's it. Cancel, then you will not face any problem in the library or loading families. So we're gonna now use the load the air handling units. So please pick up or pick out, sorry, here mechanical, open mechanical MEP, and here general components, airside components, air conditioners, and air handling units. We'll find many air handling units here. And here this air handling unit, coil, hot water, indoor, and many things, many designs, mixing box, handling units, split system, vertical packaged, chilled water, indoor, outdoor, rooftop, hot water, refrigerant, and filter mixing box. Okay, here indoor, so you may use the rooftop, hang unit, air coil, the refrigerant, horizontal chilled water. Okay, here outdoor, AHU. This is that I selected for M outdoor AHU. So you can click open, and they'll Revit will upload get it. Okay, so here the after this you will find many sizes for this air handling unit. Okay, 0.6 square meters of its coil. Gentlemen, here the level 3, but at offset 3000 millimeters. Okay, So this is the machine. We have to know, click here. Here is in, and here is the out. Out means that this is the place that the duct will be drawn to for the air distribution, and here is the inlet for the fresh air, or you may use the return air. And here is the electrical connectors, and here the create pipe for piping system, and here is the electrical for the electrical engineers. Okay, here is level 3. We know that we have here a shaft. To see this shaft, okay, I need to see this shaft here to know where we can put this machine. So we can put it here, or here, and here this is the out, and this is the out. We're going to talk about it in details now. So we can make it like this. So okay, click on the shaft. We do not need to see it here. 0. Okay. Or Control Z to know the distance. So here is the air handling unit. Now we wanna distribute or make the distribution for the air and select the air terminals. Well, first of all, we have to know that we have to use the DuctMate or any other duct sizer. Oh, I'm sorry. Okay. Right click and as an administrator. Okay. So here we're going to use equal friction method as we talked about this. Here the total CFM for the building, but we only need now, this is for the sizing. Gentlemen, this size you have to know what is the duct 22168. So use 22168. Okay, and foot per minute, it may reach 2.5, it may reach, we said that this is 2.5. Here is the air velocity. Okay, yes, maybe 5 foot per minute, or for the main duct here. Now we have to take a look on the main duct. The ranges maybe 1000. Okay, 1100. So we may use 1002. This is the main duct. Foot per minute. Notice that we have to take a look on the CFM, and here, so this is the pressure rate. We have to make it constant. And here's the equivalent diameter, and here is the clear height and the width of the rectangular duct. we have to reach aspect ratio near close to 1. So make here this 200, 22, 168, 168. Okay, 32. Now make this 40. Okay, 168, 72, 40. Is 1.8. Okay, so the clear width 440 and 72 here. So let's see the duct size. Create duct. Notice that the width is 43 and the height is 37. 43. If this is 43 or 40, 14 multiplied by 72.41 is 2896. 96.4, and in Revit is 43 multiplied by 37. Of course, this is small. This is a small duct, so this can't be. So use the next C 53 and 39. Still smaller, so we have to click cancel, and use the next. Okay, use 1.1 to see the duct. Here is 65, 5 multiplied by 40, 3,000. Okay, let's check out 0.9. The duct here is 6539, 2535, 2535. I need 28, so you have to select the 1.1 to be sure that you will that this Iran unit is has the power, enough power to supply you with the required amount of air. Okay, now we have to only check out the areas that we need to supply. Here is 5 to 7 plus 5 to 8 plus 558 plus 131 plus 609 plus 548 plus 131 plus 870 plus here are equal 4 diffusers 397 for the CFM, but we're gonna now see if this diffuser we can change this diffuser. This is it was a rough calculations, or it was a rough selection for the diffuser, but I only need now the CFM. Okay, so the total CFM for the third story or level is 5490. Now we have to get the size of this main duct. Okay, and here is the deal. Just make this 5490. Okay, and okay, you can get this the last friction. 22168. What will happen? Okay, and here so the friction 5490, and okay, so according to the foot per minute now, okay, it's not a problem, it doesn't matter, but you have to be careful when you select this data. Okay, and here we go. This is the size to 1000 for the main duct, and here the friction gonna be 95. It's okay. 59059, and this will be fixed. Okay, increase this to 30 to see. Put 30 to 23, and divide 30 by 23.49. It's 1.2. Make this 25, and see what will happen. What will happen here? 590, and here is okay. Java is not easy, but you have to be careful. So 2825. Okay, 2825. Clear width 25. This duct, this is the main duct here that will be used for the entire building, but we're gonna use a branch from here, this branch, and here the main duct for this level. Okay, 25, 28. 25, 28. Can make it Control Z. Okay, so take a look on the third, and here is the main duct, and here is the air handling unit. Okay, You can choose air and unchilled water, but just for this tutorial I'm showing you the procedure, the common procedure that you will do. You can change anything you want from the family, and here is the duct for this area. Make it realistic. Okay, now we do not need this. So now this duct will be used for this area. Also, there is another way to divide the areas by, here you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 places, and here the same 6 places. Okay, another way to determine the size of this duct, we can make a duct here and another duct here for the opposite side. So this is, I think this is better for this distribution. So let's add again 5, 4, 8. 6, 0, 9 plus 1, 3, 1 plus 1, 3, 1 plus 2 multiplied by 3, 9, 7. So this is the total for this. Here we're gonna use main duct for this area. Two, two, 1, 3, and here 9. Okay, yeah, I got the problem. If you change the feet per minute, you have to be sure that this will change. So our importance now is 2213 CFM with 1200 foot per minute, and of course we're gonna use 0.10 for this. Mm, 0.1. If you change the foot per minute, and this will change. Okay, you have to set 2 and get the third. So here maybe 15, 2213, and here I think this is good. 3 divided by 15, the aspect ratio 1.2. So 15, 18, 9, 3. 15, 18.93. Okay, here is the new duct. Now we have to distribute the air for these areas. Okay, for the distribution, here go, and we may move this 15, 19. Here, gentlemen, if you find that this is 18 and this here is 15, you can make this 20. Okay, the nearest yes, so 1520, it's good, but please delete this. Fifteen 20. Please select the appropriate position. Suppose that you find it here. Okay, and then you come like this. Okay, we need to get a branch for this location. This location is 131 CFM. 131 CFM. But the foot per minute, it may be for the residential here. 131 here, we have to first see the diffuser. Now we're gonna talk about the diffuser. So to sum up, we selected the air handling unit and set it in the right position on the roof. Okay, then you have to make the size or determine the size of the main duct for this area. Okay, using the catalogs and the foot per minute, recommended foot per minute, the main duct, and the CFM. Now for every zone you have to select the appropriate diffuser. Here we have the ceiling diffuser performance data, and here this is the decibel, 30, 36, 43 decibel, and here is the neck velocity in foot per minute. Okay, and here the CFM. So according to here the decibel, notice that if the foot per minute increases, the decibel will increases, and so on. So we need 131. So I think that this is the CFM, and here is the foot per minute. So you have to know what is the recommended for the foot per minute for this location. Okay, from this we'll find here, we may hear the general open offices, and here the decibel. The recommended decibel is here is the average is 45 decibel. 45 means that as an average you may use less than 45 or more than it. So we need 131, so it's okay to use this size. And notice that here is the this is the size 12.5. 12.5 means this is the square. It's a square. Length and width are equal, 12.5 inches, and 5 inches in diameter of the neck. So this is the neck diameter. It's 131, and here is the decibel level. I think it's okay. And here is the minimum and the maximum radius. So let's take a look. The recommended here, the R average, you have to calculate the R average. The R average is the R minimum plus the R maximum. The R minimum here is 3, and the R maximum is 6. So 3 plus 6 divided by 2 is 4.5. So here is 4.5. What is R1 and what's the R2? Suppose that this is the zone. Okay, and R1 is 5 feet and or 5 foot, and R2 are 7.5. So this is R1 and this is R2. Get the equation and put R1 here and R2 here and multiply R2 by 0.75. So the R average are 4.5 and R1 is 5. So here R average is not greater than R1, so you have to select another diffuser until you get the R average greater than R1 and smaller than 0.57 multiplied by R2 and so on, and you have to know that you have to be in the safe side for the decibel level. Here you have to be sure that the decibel level is good. Okay, so 131 I think is not good, so you may use the other. P plus 7 divided by 2 is 5. 131 for the same decibel, or you may get 4 and 8 plus 8 divided by 2 is 6. 6 is greater than 5. Okay, so you may select this and the decibel is good, is not greater than 45. So this is the 15 and 6. And here is the CFM. This CFM can provide 131, I think. So and so on, gentlemen. So according to the noise level, you have to be sure that you are right. So 255. So here we wanna get the 255 air terminal. Click on the air terminal. You'll find many diffusers here, because I have already loaded the family. I think it's in mechanical MEP. Here's that components, and here are the terminal units. Here are the air terminals. You will find many diffusers, exhaust grill, hood, grease hood, louvers, range hood, return gesture, diffuser. Here are the diffusers that you need. Okay, so please select what you want, and then you will find many sizes, and if you do not see the required size, you can edit type and duplicate and get the size that you want by changing the diffuser height here. I'm not sure about the diffuser height too, but you can change the height and the width, and you're gonna change the size. Okay, so we need here 255. So here's 15 inch and 6 inch in diameter. 15 inch. Okay, make it, so we may rename this. In millimeter, 381. Okay, and 381. And the neck is 6 inch in diameter. 6 inch for neck. Okay, so 381. So here is the deal. Change this to 381, and here 381. You may also change this 381, but I'm not sure of this. 381. and the duct diameter in inches is gonna be 6. Okay, the duct diameter, here's the neck, 6 inches, and here's gonna be 3. Okay, so this is the new. You cannot see it right now. You have to make the offset 300 millimeters from level 3 to get the diffuser. Please, you have to be very careful to get this diffuser at the right position. Make it here. So this is the diffuser. Okay, we need here to get a duct. This duct may increase in its length. Okay, 131 is 4.47 and 375. So here this is maybe 6 or 5, and here is 4. So duct is a project. And 4, or you can make it 6 and 4, 5 and 4, 6 or 4. Okay, click here, and here we go. This is the branch. Look. So here is the rectangular diffuser with the required size according to this, and so on. Every zone you have to select the appropriate diffuser for it. Okay, and here are the questions. The elbows, radius, or the connections for the ducts, and here we go. You have to know the appropriate connectors, or the elbows, and L divided by L to W, L to D, and every pressure losses due to elbows. We have here many kind of elbows, and here H, W, and R, and here H to W, R to W. Okay, we'll find here in Revit 1.5 W. Is here 1.5, here R to W, and these things you have to be sure many things. And here is the T's and many things, and here's the meter width with turning vanes. You can see that you can change 1W, 1.5 to W. Okay, also you can click here and edit family. You can edit this you can here click on the duct itself. Find here that this rectangular duct uses radius elbows and tabs. You You can edit type and routing preferences, and here is the that's why the this duct use 1.5 W, and you can make the default 1W, 2W, and here standard. And here are the junctions. These are the junctions. You can use the junctions, and there are the cross and many things. And here is the transition. If you there is a transition with angle 15, 30, 45, or 60, you can use this. And here the multi-shape transition, and here is no oval, and the union and the cap. If you do not see these things, you can load family and go to duct fittings. You'll find multi-shape tabs and transition, and these you can get what you want. Tabs, okay. And for the oval, you'll find many things here. The unions, the Y's, and here are the round, rectangular, transitions, and so on. Okay. So this is this duct. For this zone, also you can get this. You can get this here to avoid the branch problem here, but we can use it in this tutorial. It's no problem. Let's see. Oh, I'm sorry. We have here this 609, 609, 131, and 397. Delete this and delete this, and here we have the total minus CFM for the third level, and okay. Eight 96.4 131. Okay, we said that we have here 2213 CFM, and now we have 2213 minus 131. This is equal 2082. We have to use this CFM 82 to know the next. Sorry. Two, and here is the for the equal fraction 101. Okay, notice that here the foot per minute it decreases, and here is make it this 80. $17, $15, 2082, and same. Okay, 15, 17. Okay, we make this 18 and make this 16. Add duct. 18 and 16, and from this. Oh, notice that here we have a problem due to transition, and here we go, so it's okay now. And here is this, and here is the transition. You can change it 45, can make it 13, 30. It's gonna be like this, or so this is the appropriate. We're going to level 3 to complete. We have here to get required for this. Okay, from this zone. Gentlemen, as you see, you have to make these things until you get the required air distribution. Here, I think that there is another distribution for the air or for the rooms, and here 131. Okay, so it's okay, no problem. It's just I'm telling you, do not please follow this drawing. I'm just telling you the procedure. This is maybe this is not maybe the zone that we need to distribute. Okay, here. Then you will find here the other distribution. Here the duct. Suppose that you wanna supply this room. Okay, we need now to read the drawings according to these drawings. Okay, so it's okay to make things not right. This will tell you how to avoid the problems in the future. Okay, this is the diffuser. This diffuser is not for this room, so basically or simply you can move it here for this room. This is 131 CFM room. Okay, and we do not need this. So actually we need to distribute the air to this room, then this and this and this and the other two terminals. So what we need to do now, sorry, there was a problem in this drawings and I got it. Also have here something that we do not need, but here is the diffuser. Okay, the same. Okay, to 113. In what will happen? 18, 16. Okay. Okay, 397, 397. Notice that 4 per minute increases, and here is we're gonna use 9 and 10, or both are 10. Okay, so the CFM 397, go to the same method, three nine seven 397 CFM in this range 397. I'm gonna use 420, and according to the minimum and the maximum, but here according to this area. Okay, according please to this area, you have to select the appropriate diffuser for this zone. I'm gonna use it roughly, so we're gonna use this, so 20 and 8 inch, 20. So we're gonna here, we have to get the edit and make duplicate, 8, 8, and the neck, in the neck, and here, and 8 inches. We'll find here 4 and click OK. And here is our diffuser. Make it maybe here. So this is the diffuser that we need for this place. Okay, make it here. Or use it like this to install it. And here we go. So we have here, and we need for this and this and this. The same here. We need the same 10, 10, the same diffuser. Have to get weights. Okay. Even if it is difficult for you to get or to make this equations or make this equation, you may make it like this, the same. The distance from here is x, and the distance from here is the same x, and the distance between them are 2x. Or you can make another method for the distribution to be very sure that the distribution is okay. We have here 2 and 5.4. And length okay. And get the diffuser, and here is the air terminal. So the same air terminal, put it here, and of course we'll get it. Okay, and here we go. So we have just finished this. Now we have this is 2 multiplied by 397. So we have finished 794 and 39794. So what we need now is 1419 CFM for the other locations. 41049. Okay, notice that here are the foot per minute. Make this maybe 20. Make it 15. Okay, 15. Okay, here is 15 and here is 14. Okay, make it 13. Okay, and we can add the new duct. The new duct. Duct is 15 and 14. Or make you can make it 16, or and here is 14. Notice that here is the transition. Automatically Revit use this transition. Why? Because this duct is this duct. Edit, edit, and you'll find here for the transition. Here is the angle 45. You can make it 15, 30, or 60 as you like as a default. Okay. So we need to distribute for the other areas 1, 2, 3, 4. Okay. Can make this 4,000. 5,000 like this, and we need a duct for 131 and this zone. Okay, 131 plus 609 74. So our CFM now is 740. Now the foot per minute decreased. We have to make sure that this foot per minute is what you want. If you do not want this range, you have to change this, but from the beginning. And here is 15, make it 9, 11. So we're gonna make one 11 and the other is 12, or make it 12. So we're gonna add duct. 12, 12. Like this. So the question, can we increase its length? Sorry. No. So we have another solution. Make the same duct. 12, 12. 12. Make it like this. Okay. I think we can select this. Cancel. Select this. Connect into and select this duct. Okay, it's okay now. We did it successfully. So notice here that we have this duct and this diffuser, and then we are gonna complete our distribution, but of course we have to decrease this length to 5 maybe. Sorry, there is something wrong. Oh, sorry. There is something wrong here, so please be careful when you use this duct from the first time. Then what we need now is 740 minus 609. Oh, sorry, we need here 609, okay, 609, 9. Now that the foot per minute decreases, and here we make this 10 and see. So I'm gonna make both are 11 or 12. Duct is okay. Save the project. Now both are 11 here. 11. And here is so this is the transition due to the decrease in the CFM, and select the first 609 CFM of course 609 CFM in the range of the recommended decibel 609. You can use 600 or you get 655 is up to you. Okay, but you have to know that this is not will not give you the same distribution according to this equation and the dimensions as I said. So here 6 is going to be 25 and 10. 25 6 3 5 millimeters. We have here air terminal. Yes, 635. And here is the diameter of the neck. We have here as a standard from Revit 20, and here is the neck 9 inches. Where 3 6 3 5. I'm sorry. Let's Control Z. I need 6. And with this neck, gentlemen, I think that I did it by the duplication, but here is the another diffuser. This 635, and here is the 635 with this neck. So this is a standard 3000. Okay, you can edit this type. You'll find here the duct diameter or the neck diameter exactly like this, 10 inches, and here is the 25 inches. 25 inches is 635, so you can use it without any problem. Notice that is bigger than this diffuser. Okay, set it here. Okay, and here 11. Okay, add duct. Add the same duct 11. Okay, so we distributed successfully this area and this area and this area and this area. Now we have to get the same for this these two areas. Okay, here can complete the distribution for here is the same for 131 but plus 131 and 548. Here on the other side. Okay, I told you guys that this drawing is another drawing. Okay, we only need the CFM. Okay, go to the duct and get the total 679 CFM, and here we go, make this 10 and this 12. 12. And here the 131 is, we're gonna need the same diffuser like this. So this is a rectangle duct. Click on this diffuser and just copy it. Like this. You can change its position. Please be careful, you have to make it in the middle, and let's make it 4000 and just okay. Connect to this duct. Okay, we did it again. Now the last 548. 548. It's gonna be 10 and 10. So we're gonna add duct 10 and 10 due to the decrease in the CFM. I'm sorry. And 548 diffuser, 548, 548, 548, 545. You can use this, and here are the minimum and the maximum. As like I said, you have to be sure that this equation is good, and so it's the same size. We're gonna use the duct or the air terminal 63. Yes. And it's 10. Okay, here I think here is a problem. This is 10 by 12, and we wanna yes, no problem. Okay, let's start it from here. Okay, let's see the 3D. Okay, gentlemen, here is the last diffuser in this area, and here is the distribution. This is the main duct, and here is the branch, and those are the other branches for this and this and these zones. We will not distribute air for these zones because they are bathrooms. Okay, so as an exercise for you, you have to complete the building, the other side of building. Please do it by yourself. Now I've just finished this tutorial to save the tutorial's time, and also you can here decrease the length of this duct. We do not need more than this. Also, yes, you can make it 3. Okay, we'll find the problem. So it's not a problem. I think here click on view and analyze yes, you can see show disconnections in the ducts. If there is any disconnections in the ducts, yeah, of course we have here disconnection because this duct is not closed, so it's okay, it's no problem. You can avoid it any method, but here we do not have any disconnections for this ducts. Okay, click on the disconnections, of course, and click OK. Close this. Let's take a look on the 3D again. So here we go. Okay, ladies and gentlemen, this is my tutorial about the duct design or duct drawing and the area handling unit selection. So let's sum up. To sum up, first of all, you have to get the CFM that you use by hourly analysis program by calculations, and to how you have to know how to select the air handling unit according to the catalog you use. You have here the selection diagram based on the air velocity that is available for this catalog and the CFM. Then go and select the air handling unit like this and see the distribution of the air by the signal diagram, and you have to know the pressure losses due to the elbows and transitions and elbows, and to see the velocity in the main ducts, the recommendations, and here is the selection for the ceiling. Okay, according to the decibel, you have to get the decibel from this. This is the recommended decibel. We select the average. According to the average, you go to the schedule and check out the CFM you need, and please be careful when you select the CFM based on the decibel. Notice that the decibel, if the decibel changes, the footprint changes, and you have to get the standard or the available size of the diffuser according to the equation, and here R1 and R2 to get the best distribution based on this. This is the R average. R average is the R minimum plus the R maximum divided by 2 to get the good distribution. Also, we can use the CFD tools, computational fluid dynamics, to investigate the best distribution for the air. Thank you very much. The next tutorial we're gonna talk about duct drawing in AutoCAD 2D, and then we're gonna complete our Revit tutorials. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.